Okay, welcome to part one of my 6-part series on kinematics. For those of you who solve these questions ahead of time and you show me in class, you'll get a bonus point. That's up to 6 bonus points for solving questions ahead and completing these in advance. I solve only the odd numbered problems, and the even numbered problems are for you to solve. Alright, so part one. In physics, a quantity is something that can be measured. So we have acceleration, velocity, speed, displacement, distance, and time are all considered quantities. Magnitude means the size of something. Scalar quantities only have magnitudes. Vector quantities have magnitudes and directions. Vectors can be added directly if they lie along the same dimension. For perpendicular vectors, you must use the Pythagorean theorem to find the resultant vector. Okay, for 1 through 4, draw the resultant vector. For each resultant vector, calculate the magnitude and determine the direction using these Cartesian coordinates: negative x, negative y, positive y. We can only do that for questions 1 and 2. Questions 3 and 4 are 2D vectors, so I'll show you how to do that. We'll do number 1 and 3. We have a 2 magnitude vector going to the positive x direction, so this is positive x. An 8 magnitude vector going in the negative x direction, so our resulting vector is 2 minus 8. This gives me a vector size negative 6. So it is a vector negative 6 going in the negative x direction. Vector is size 6, negative x direction. Okay, let's see for number 3. We have a vector, positive 8 pointing up, a vector, so this is the, positive y direction. This vector is pointing in the positive x direction. So we need to use something called the head to tail method. You can put the head of vector 1 against the tail of vector 2. So this is my 8 magnitude vector, and now all I'm going to do in my head or on this side is slide this vector up so that vector 6's tail is against the head of vector 8. And again, this is the positive y direction, this is the positive x direction, and the resultant vector goes from the tail of 8 to the head of 6. And I'll call this resultant vector r. So to calculate it, we'll do the Pythagorean theorem, which tells me that the resultant vector is equal to the square root of 8 squared plus 6 squared. That's the square root of 64 plus 36. And actually use my calculator for this one. 64 plus 36, and that's 100. I could have done that. Okay, the square root of 100 equals 10. So this is my resultant vector, and for a 2D, for 2 dimensions, I don't need to calculate any further, any angle or anything like that. Just note the head of vector 1 against the tail of vector 2 when you're dealing with 2D vectors. Let's see if you can do this one. Okay. Then we have questions 5 through 27. I'm going to do just 5 through 8 for part 1. Read each problem and calculate the final answers. Show work as instructed. No naked numbers, that means you need units. Round final answers to their correct significant figures or significant digits and box in your final answers. So again, I'm doing all the odd numbered problems. You'll do the even numbers. Number 5, a plane flies east with an airspeed of 700 kilometers per hour. The plane encounters a high altitude tailwind of 100 kilometers per hour in the east direction. What is the velocity of the plane relative to the ground? So if I use my vector drawing, and you don't have to do this for the subsequent problems, but I can see the plane flies east at 700 kilometers per hour, and it has a tailwind that is 100 kilometers per hour. These two are going to combine. So the plane gets a boost because of the wind. So it has 800 kilometers per hour relative to the ground. That's its speed. And I have 1 sig fig here, 1 sig fig. My final answer has 1 sig fig, and I'm in kilometers per hour. Question number 7. A lap around a running track is 400 meters. If a runner makes 10 complete laps around the track, what is the total distance covered? What is the runner's displacement? Okay, so it's easy to get the distance. The distance equals the number of laps times the length of the track. So that's 10 laps times 400 meters, which gives me a total of 4,000 meters run by the runner. That's the distance. Displacement is different. I don't add up all of the loops. Instead, I just know that the final position and the initial position are the same. Final position equals initial position. So the displacement equals 0 meters. All right. If I come here to number 8, I'm not going to solve it for you, but I will explain. You want the distance traveled after a ball is kicked 5 meters east, 11 meters west, 12 meters west, and 22 meters east. The distance is, you add up all of these distances no matter their direction. So that's how you'll get distance. Displacement, however, is different. Choose east to be the positive direction. Make west the negative direction, and you'll add it like this. The displacement will be 5 meters plus negative 11 meters plus negative 12 meters plus 22 meters. And that should give you the displacement. And if it's positive, you'll know the ball has ended up east. Positive equals east. Negative equals west. Don't forget 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs. So your final answer needs to have 3 sig figs, even though I didn't include all the digits here. So good luck with that, and meet me in part 2 when you're ready.